Okay, so we've talked about 3.1 all the way to 3.4, and now at the end of chapter 3, why don't we just do a little bit of a review? We're going to recap some concepts that we've learned before, go over some new examples, and maybe talk about anything we haven't yet talked about. Okay, so why don't we just start? Chapter 3 is all about rational functions. So if we did a full analysis on that, we would then be able to graph it. But looking at it right now, I mean, we've actually never gone over a quadratic divided by a linear. That's something new, and I'm getting kind of freaked out. Like, how would I actually tackle this? The first thing that you always want to do is A, don't freak out, okay? And then B, if you can, break it down. See if there is something that you can factor out from the top, and it might cancel out with the bottom and become an easier function. Okay, so I did actually factor out the top, and hallelujah, I actually was able to cancel out something on the bottom. Okay, so if they cancel out, that means that you have a hole at that number. So you have a hole at x equals to 5 in your graph. If these cancel out, all that's left is x plus 2. Well, that means that if I actually graph this, I should just get a graph of x plus 2. Well, that's easy to graph. It's just a linear, right? I mean, if we just graph that, you should have a y-intercept of 2 and then a slope of 1. The only difference is, instead of just having the graph, you would also include that hole right there. So the hole is at x equals to 5. I knew it should have been right here because obviously, I mean, it's linear. I can kind of just put it where the line is. But also, if I put 5 into the equation, 5 plus 2 should have been 7. Now, I can't put a solid dot there even though it is 7, because if I had originally put the 5 into the above step, I would have gotten 0 on the top as the numerator and 0 on the bottom as a denominator, and that would have been an indeterminate answer. So we do have to recognize that there shouldn't be an answer right here. Even though if we put the 5 into the second step, it would still give us a number. Okay, so that's done. Fairly easy. Let's take a look at a word problem. The maximum time, t at d, in minutes, a scuba diver can rise without stopping for decompression on the way up to the surface is defined by this equation, where d is the depth of the dive in meters. Okay, so what they're talking about is usually when you're scuba diving and you go into very far depths, the pressure on you is going to change. So the deeper you go into the water, the more pressure is acting on you. So what scuba divers never want to do is swim as fast as they can up to the surface, because what's going to happen is, like, some gas and bubbles are going to form in their body, whether it be in their bloodstream or somewhere else. And basically what happens is they could die because of those bubbles in their bloodstream. So what they want to do is actually just slowly rise towards the surface and maybe take some breaks. Those breaks will allow them to acclimatize to the pressure surrounding them, and they'll just slowly go up and get used to the pressure. So what we want to do in this question is, for the maximum time to be less than 15 minutes, how deep can the diver dive? So we only want to dive for less than 15 minutes, so how far down can we go? All right. Let's take the equation right here, and we'll say that it's less than 15, because it's going to be less than 15 minutes. In order to solve this, again, you cannot cross multiply because it's an inequality. So bring the 15 to the other side and put these two fractions together. So I'm going to need a common denominator, which means I'll need to multiply the top and bottom by the same thing. Once I have the common denominator, I can open up the brackets, being very careful with the minus in front of it. Okay, because it's going to change all the symbols. All right, so I get a negative 15d and a positive 150. Then you're going to collect like terms and you're going to factor out the top. By factoring out the top, you see what your x-intercepts are. So in this case, your d-intercept is going to be a positive 45. That's going to go into my interval chart. And then down here is going to be my vertical asymptote, which is positive 10. So that's also going to go into my interval chart. Since there's no equal to sign, there's going to be round brackets around this one, and the vertical asymptotes always have round brackets. Okay, so take a look. These guys have round brackets. right here, and then infinity signs always have round brackets. I have both parts of my original equation, which makes a t at d. Okay, so we're just going to start to choose numbers, and we fill in the rest of our interval chart, and we have our answers. Okay, so we wanted less than, which means this part and this part. So these two are our intervals that are our final answers. Now, we got to figure out if this is actually reasonable. Like, what makes sense in terms of d? D means depth. There is no such thing as negative infinity depth. There is also no such thing as infinity depth. So you need to kind of, in this case, really figure out what is a reasonable depth. So I would say definitely a depth of 0, including 0 would make sense. We can't include the 10 because originally there was, I believe, an asymptote there. Okay, and I think a depth of 45 meters, like, are you really going to swim that far down? You could. It's really up to you how you want to answer this question, but definitely this part would probably be the most reasonable. So I wrote this: the diver dove less than 10 meters in 15 minutes. Like, diving 45 meters in 15 minutes, I don't know, maybe it could be done, but it seems a little bit questionable. Okay. This is our last example where we have to do some sort of a full analysis on this quadratic over a quadratic. So it is irrational because it's in fraction form, but we've never done a quadratic over a quadratic. So let's just break it down, and then maybe I can do a full analysis. Okay, so when I factored out the top and factored out the bottom, I noticed that there was something that was the same that could be crossed out. That means there is a hole at x equals to -1/2. All right. But what I also want to know is, what is this coordinate, just in case? So I take the -1/2 and I put it into each of the x's, and I solve for g at -1/2, and I got -3. So at this coordinate, -1/2 and -3, there will be a hole in the graph. Since these guys crossed off, I actually have just these two left over. Okay, that looks like something that I've done a full analysis for. So what I'm going to do is just start doing the analysis where I figure out the vertical and horizontal asymptotes. Vertical asymptotes should be down here, so x equals to -2. Horizontal asymptote would be taking the coefficients, so there's my 1 and there's my 1. So those guys divided by each other gives me 1. Perfect. All right, then I'm going to do the end behavior analysis. So I got my -2 from the right and from the left, and then this guy, the 1, from all the way at positive infinity and negative infinity. So let's just take a look at this and where the hole is, and then we'll just kind of see maybe what our graph kind of looks like. All right, so we have our vertical and horizontal asymptotes. The hole is at -0.5 and -3, so there it is right there. And right around this guy, from the right-hand side, it was going toward negative infinity, and from the left-hand side, positive infinity. Then when we went towards a positive infinity for the x values, it was going towards 1 from the below, and then negative infinity, it was going towards 1 from above. So we connect it and we get the overall parts of our graph. But if we want these two dots as well, we're going to have to do the analysis for the x and y intercepts. Okay, so here's our graph, and we want to bring this to the other side. Now there's a 0 here because the y value is going to be 0. So when we multiply them, this guy disappears and it becomes a 0. So x minus 4 is equal to 0, which means x equals to 4, and there should be a dot right there. When we find our y-intercept, we put the x as 0, and then basically what happens is we just take these two guys and divide them by each other. We get -2 as our x-intercept. So here we have two dots, here and here. Everything together should make your g at x. Okay, so that's a recap of everything together, and on to chapter 4.